Hey everyone, intriguing chat today around AI meeting the data center with a true industry insider and expert from Spirent. As we all know, AI models are putting tremendous pressure on the data center as bandwidth demand grows, and we're rapidly trying to increase data center speeds, moving from 400 gig to 800 gig to 1.6 terabyte just to keep up. And Spirent is moving testing into the AI fast lane as well. Aniket, how are you?
I'm good, Evan. How are you?
Really exciting time to chat. Thanks so much for joining. I have lots of questions. Before we dive into those, maybe introduce yourself, a little bit about your background and role at Spirent.
Sure. So my name is Aniket Khosla. I'm the VP of Product Management here at Spirent. I manage what we call the wireline portfolio, which is essentially the core Ethernet business that we have here. Hardware speeds going from 1 gig all the way to 1.6 terabit, like you mentioned. So I manage that entire product portfolio. I've been in the industry Spirent is in, which is essentially test and measurement for almost 22 years now. So
Wow.
I've been living and breathing this stuff since I graduated from college.
That's fantastic. So you've seen this evolution over the decades. But what's new, what's different is AI workloads. And, try to give us your impression. What's new and different from AI workload versus traditional data center workloads you've seen for so long?
So, AI workloads are fundamentally very different compared to traditional workloads, which is why even the way AI data centers are being built are very different, right? They are computationally incredibly intensive, right? You're talking about sets of data that are absolutely massive that in that do require specialized hardware like GPUs to handle and manage, right? So this is not your traditional data center that just had servers and CPUs that could, handle flows, web traffic, so on and so forth. You're talking about computationally intensive workloads that require specialized hardware. And more than anything else, Evan, in the AI backend data centers, the networking aspects become very mission critical. In a traditional backend data center, if you lose a packet, you can always retransmit the packet. There isn't a big impact to the network if you have latency and packet loss. But in an AI data center, if you lose a packet or you have high latency, it's pretty much a death knell because everything comes to a grinding halt in an AI data center when you lose packets. So the networking aspects also for an AI data center are very different than your traditional data center. And the demands that are placed on the network are very, very critical.
Really well said. And we've seen these incredible announcements around the growth of hyperscalers. Every day there's a huge new expansion or new investment, huge opportunity. But what are the challenges that these projects create? And, how do we overcome this?
So that's a very good question, Evan. If you look at the way a lot of the hyperscalers and the customers we're dealing with who are looking to deploy these massive AI data centers, the way they're trying to solve the problem associated with these massive data sets is to throw more GPUs at the problem. Okay, so basically saying, okay, we'll just give you more GPU capacity. But there are studies that show that very often than not, just throwing more GPUs at a problem actually exacerbates the problem in an AI data center. There are multiple choke points or bottlenecks in these backend data centers that cause issues in the training environments. The network is one of them. So the challenges we're seeing with our customers is they are not really doing a lot of thorough testing in checking or validating the performance of their network fabric to see what impact that's having to the training environment. So they're basically going in very often blind, deploying these GPUs, and then finding all these issues with packet loss, training times taking much, much longer than they should. So that's where the challenge has been. And some of the other customers who actually do test have no way to test apart from actually building out these GPU clusters in their labs, buying real GPUs, buying real servers, and running these tests to validate the fabric. That does not scale well. If you can get your hands on GPUs to start with, right? The lead times are long. They're incredibly expensive, not just to buy, but to also manage and maintain over a period of time. So that's where we're seeing a gap in the industry right now, where there isn't really anybody coming in and say, look, I will help you test your network fabric in the way that somebody who's an expert in the test industry like Spirent has done for decades. So that's where we see a huge gap in the industry right now.
A really important insight. And as you know better than anyone, Ethernet still plays this fundamental role in the data center, going back to 1973 and Bob Metcalfe at Park,
Right.
and the incredible creation of Ethernet. But what's the impact of AI on Ethernet networks?
So that's a good question, right? So right now in the AI data centers, you have two main technologies which are used for communication between all the different clusters. It's either InfiniBand or it's Ethernet, right? InfiniBand is proprietary, and it was essentially purpose built to be lossless, low latency. So it serves that particular cluster communications very well, but it is proprietary, right? It's expensive, it's proprietary. Ethernet has just been a resilient technology that's been around, to your point, for decades. It is ubiquitous, it is open. So we're seeing over a period of time that Ethernet share in this cluster communication is going to grow, right? So Ethernet will evolve, it will adapt, it will have extensions added to it, if you will, for it to be more lossless and deal with congestion better. Keep in mind, Ethernet was not built to handle these AI workloads, right? It is doing incredibly well in what it's doing right now, but we do expect evolution in the Ethernet space so that it can adapt better to managing these AI workloads. So Ethernet in the long term has a major part to play, whether it's economies, whether it's the fact that it's an open standard, the fact that it's ubiquitous, well understood. So we do see over a period of time, the uh, Ethernet will grow even more in these AI backend data centers as the communication fabric, if you will, between the clusters. Definitely.
Also interesting. So when it comes to Spirent, you guys have been around for as long as I can remember, certainly decades in the industry,
Right.
and you've done it all. But what needs to change as far as testing approaches are concerned with AI and hyperscalers? What new thinking needs to be brought to the challenge?
So, like I mentioned, the traditional data center and the AI data center are very different in the workloads that they manage. Okay. Spirent has always created those, what I'll call traditional workloads, right?
Mm.
We send traffic at line rate. We can do 1 gig all the way up to 1.6 terabit, to your point. But those data patterns do not mimic what an AI workload looks like. So when we started to talk to customers about a year and a half ago, we realized that we had to do something fundamentally different in the way we create our traffic loads to mimic those AI workloads. So that's what we set out to do, right? So we've been able to change the traffic patterns that we generate out of our products to now mimic traffic coming out of a GPU, right? So we are simulating these AI workloads now in our product portfolio, and it's fundamentally very, very different, right? I've spoken to customers, Evan, who have tested their network fabric using, regular testers just running the old school tests. And in those
Mm.
test environments, everything ran beautifully. They had no packet loss, no congestion, nothing. When they actually deployed, things went sideways very quickly because the traffic load and traffic patterns were very different. So now when we go in and say, look, you cannot use these traditional testers. You have to use a new age tester like Spirent with these new capabilities, because we can stress out your fabric before you actually deploy and show you how your network fabric is going to respond when you have congestion. So it's a fundamentally different way in which we are creating these traffic patterns now on our product lines to mimic these AI workloads. And that's what's fundamentally different. That's what's fundamentally different.
Wow, big changes ahead.
Yes.
And the whole industry really looks to Spirent for best practices and tips and tricks and advice. So what are some of the high level best practices for testing validation and when it comes to, AI success, short term, but long term?
We have this motto internally: trust but verify. Right. A lot of
Mm.
instances we see, whether it's a big enterprise customer, whether it's a hyperscaler, they will typically rely on their vendor to do a lot of the testing, right? They say, okay, you know what, we're buying the switch from you. You guys should test. Our recommendation is always trust the vendor, but verify this yourselves, right? So from a best practices standpoint, from an AI data center model, we absolutely recommend stress testing your fabric out. Look, there will be multiple congestion spots and multiple bottlenecks in an AI data center. Eliminate the fabric as one of them, right? You might have issues with memory access or size of data, but remove the questions you have around the network fabric by actually doing the tests, right? So know what your hotspots are. You're always going to have some sort of problem in your network. Know how to deal with it or react to it by doing the right testing before you deploy. That's what we always recommend to our customers. And now the fact that we can actually simulate these workloads on our hardware will give our customers a lot more confidence before they deploy, right? These GPUs, like I said, are not cheap. You don't you the last thing somebody wants who's deploying a massive GPU cluster is to have their GPU sitting idle because of network congestion, right? People are spending billions of dollars here building up these massive clusters. And the last thing they want is for the GPU to be sitting idle because the network has congestion and there's packet loss or latency. So trust but verify, definitely.
Great point. And you work with, so many operators, carriers around the world. It's probably tough to pick one or two examples, but maybe you could talk to some of the operators who you're managing to help struggling with, latency, bandwidth issues around AI training, inferencing, other related issues.
Sure. Sure. So I can give you one example of a major carrier that we're working with right now. Okay. They are in a situation right now where they have to pick which vendor gives them the most lossless fabric. Okay. And they have no benchmarking methodology to do this. The way they're doing it right now is they're actually building out labs. I think right now they have maybe 64 GPUs. They're having a tough time getting their
Wow.
hands on these GPUs as well. And they're running tests to benchmark different switch vendors, right? They're saying, okay, is switch vendor A better than B, better than C? Okay. They have struggled to run these tests, A, obviously, because they don't have enough servers and GPUs. The second major issue they're facing is scale. A lot of people don't really understand how all this stuff works, right? And third, when they're building out these real labs right now, they have to come up with the test methodology. They have to do the scripting. They have to do the benchmarking
Mm.
themselves. So they've really struggled. They've been able to do tests of up to 64 ports or 64 GPUs, no issues. But they know their deployments are going to be much bigger. And that's where we've come in and said, look, take our specific product line, our piece of hardware. We can simulate not just 64, we can simulate thousands of GPUs for you. And then you can really stress test your data center architecture using our equipment. We don't just give you access to it immediately, but we also, given our expertise in test, right? We make it easy for you to use. We come up with the methodology, we come up with the benchmarking models, and we give you the data that you want. Things like what is my job completion time in training? What is my long tail latency? So we take the cost and complexity out of building a real lab, right? Versus going in blind. So we are that glue right now that can help these customers really scale out, take the complexity out of it, lower their costs, you know whether it's product cost, maintenance cost, expertise, hiring the right people. We take all that out. So in this particular instance, interestingly enough, Evan, they ran a bunch of tests. They simulated about 256 GPUs using our hardware. The tests clearly showed that one switch vendor was so far ahead of the other two
Mm.
that it really helped them decide very quickly which switch vendor they were going to go with. And if it wasn't for us working as closely as we were with them, they would have struggled with that. They really would have struggled with that.
Wow, amazing work. And just to think, we're just getting started, really, as an
Right.
industry with AI in the data center. We're going to see a tsunami of deployments over the next years. You're doing such important preparation, and give us a snapshot of the Spirent solutions and products to meet these networking needs for AI, maybe the different segments you serve and some of the product overview.
Right. Yeah. So the major product launch that's slated in the next 30 to 45 days is a piece of hardware that we own. It's called the A1. It's a 400 gig piece of hardware, right? It essentially
Mm.
has 400 gig ports on it, and Spirent's flagship application, Spirent Test Center, essentially runs on that piece of hardware. And what we've been able to do is almost give that piece of hardware that we have a different personality to work in sort of an AI mode, if you will.
Oh,
So
wow.
the so the software then kind of programs the hardware that we have and and gets each 400 gig port to act like a GPU, right, and create the
Mm.
workloads coming out of that, right? We can do up to 16 400 gig ports. We can then scale each of those ports out to be multiple 200 gig ports or multiple 100 gig ports. So we give you a lot of density in a very compact to use small form factor. So we're replacing a lot of the complexities of server setup, GPU setup, and simulating that in our hardware. I
Mm.
will candidly say, Evan, this is our foot in the door. This is our first major product launch that we have that is specifically designed to target the AI data center fabric test. I absolutely expect once we get our foot in the door to a lot of the major hyperscalers, the NEMs, the carriers, we will evolve, we will learn, we will put out more product, right? So this gets us in the conversation. We've had me personally, I've spoken to at least 40 customers over the past 3 months, demonstrated this stuff. There's been, a resoundingly positive feedback coming from people that, they needed this 6 months ago or a year ago. So
Mm.
at least we're here now. So, like I said, this is our first foray in. There are a bunch of other things that we're creatively, thinking about in the background right now. But I think this is going to be an incredible learning experience for us. Get our foot in the door. This is the part of the market we are very comfortable with. We understand the networking world. We understand the Ethernet world very well, right? We've had that experience over 20 years. So we've taken that, adopted it to the AI space, and I absolutely expect a lot more innovative products coming out of Spirent within the next, years to come.
Wow, exciting times, such important work. So beyond partnering with Spirent, how else should folks prepare for this really transformative impact on the data center, expensive impact with AI? How should they get ready?
So I think someone said this. I don't remember who it was, but this is kind of like the iPhone moment, Evan, from 2010,
Mm.
right? This is just the beginning. We're just starting here, right? The iPhone changed the world. It caused the massive expansion it did in the data center market. I expect AI to change the world in different ways moving forward. So as an organization, if you're looking at AI as a model for you to, transform yourselves, to, put different products out on the market, our first recommendation is know what your strategy is. Like, know what you want to do, and more importantly, how you want to do it. Right? Building your own AI data center might not always be the answer. Right? You're seeing newer companies that will start to offer AI as a service. CoreWeave is one of them. I'm sure there are other. I
Mm.
think Cloudflare does it as well. So know what your strategy is going to be on how you're going to adopt and adapt AI to your business and to your business model, and then see what that means to you in terms of how you're actually going to deliver that outcome. Some people might choose to buy their own to build their own AI data centers. Some might choose to have an AI data center as a service. Either way, test. We highly recommend that people test so that you know what you're up against, right? Because at the end of the day, you're providing the service to your end customer. That has to work well, right? The quality of experience has to be flawless, if you will. So know what your strategy is, know how you're going to build this out, and then we always recommend, like I said, trust but verify. Absolutely. And only then, will you be best prepared to know what, how this is going to work for you, and so on and so forth. So that is our recommendation for sure.
All great advice. So let's change that from trust and verify to test and verify. Something you
Test and
know so
verify.
much about. Well said. Congratulations on all the success personally as well. I know you've been
Thank
on the
you.
road so much at industry events and customers. Maybe you'll have a little bit of R&R this summer. But thanks for the insight. Thanks for sharing your vision and mission with my audience.
Thank you for having me, Evan. I really appreciate it, and I look forward to talking to you again soon.
Likewise. We'll see you then. Take care, everyone. Thanks.
Thank you.